Hello everyone, welcome back to the class of Math 1450, Math and the Modern World. And this time we are moving into the discussing in section 5.5. It is about graphs, and specifically graphs of linear equations with two variables. Graphs of linear equations with two variables. And we will not talk about the inequalities. Graphs of inequalities for now. And so section 5.5, graph of linear equations, graph of linear equations and inequalities. First of all, let's just introduce the so-called rectangular coordinate system. Rectangular coordinate system simply it is formed by two perpendicular lines. The line along the horizontal direction, it is so-called the x-axis. The line along the vertical direction, it is the y-axis. In either each x-axis or y-axis, it is just a real number line. They just arranged, we put them together and make them perpendicular. Together they form the rectangular coordinate system. Hopefully if you look at the screen, those two perpendicular, the x-axis and the y-axis, they do separate the entire plane into four quadrants. And accordingly, those quadrants are labeled as the up right corner, it is quadrant 1. Then the up left corner, it is quadrant 2. The lower left corner, it is quadrant 3. And the lower right corner, it is quadrant 4. And it is also worth to mention 1, 2, 3, 4. It is very true, actually, math-wise. You see a lot of things we have in the graph, they are arranged in the counterclockwise direction. Take a look. Does it make sense to you? From 1 to 2 to 3 to 4. They are in the counterclockwise orientation, right? Counterclockwise orientation. So that is the xy plane or the so-called rectangular coordinate system. And then you may want to know what do we use? What is this rectangular coordinate system for? Put it in a very simple way, the rectangular coordinate system, in a rectangular coordinate system, every single point can be represented by a point. A point, it is a point, it is an ordered pair. It is an ordered pair. Like we look at this rectangular coordinate system, we have a point 1 and 3. It represents the ordered pair 1 and 3. 1 and 3. By the way, those dotted lines are not a part of the graph. This simply indicates how we find out the x coordinate 1 and the y coordinate 3. In the ordered pair, the first coordinate, simply it is called as the x coordinate. The second component of the ordered pair, it is the y coordinate. X coordinate, y coordinate. A single point is an ordered pair. An ordered pair is a point in the xy plane. And then sometimes we may have some special ordered pairs. What would happen, like one of the coordinates tends to be 0. So indeed, like the point 0 and 4, the x coordinate is 0, right? You want to keep in mind the x coordinate is 0 simply means it will have to be a point on the y-axis. And the y coordinate is 4, so you see this kind of bluish, I just call this as bluish, dot. It is for the ordered pair 0 and 4. And also we have another ordered pair, -2 and 0. So you see, first of all, the y coordinate is 0, which means it will have to be somewhere on the x-axis, and such that x coordinate that's -2. So that is this point. It is for the ordered pair -2 and 0. And the ordered pair, it is a point. In the rectangular coordinate system, an ordered pair, it is a point. A point, it is an ordered pair. Okay. Any questions? All right, let's move on. You may wonder, why do we need to consider ordered pairs? Because remember, we have equations, we have linear equations. When we have linear equations with two variables, and indeed there are many solutions, there are infinite solutions. And each solution appears in ordered pair form. Okay. So some basic things on linear equations. Usually we consider this fashion. Ax plus by equals c as a standard form of linear equation with two variables. And with numbers, hopefully it's a little easier to see the equation with numbers. X plus 4y equals 8. So if you want to match the notations, clearly we can tell a is 1. Remember, for the single x, looks like there's not a coefficient, right? But you want to understand the coefficient. X does have a coefficient. Every single notation has a coefficient. The coefficient for x simply is 1, and the coefficient for y is 4. Okay. So this turns out to be a linear equation. And sometimes you may have a linear equation may not just match the standard form directly. So this is the equation I'm talking about. Y equals negative 3x plus 4. Clearly you don't want to say that's in the fashion of ax plus by, those kind of things. And indeed, if you know the equation of lines, this is the so-called slope-intercept form of linear equation. Okay. But let's say, how do we really match the standard form? It should be very simple. This is what I did because we are considering operations on the equation. So first I added both sides of the equation by the term 3x. Add 3x to both sides. So actually, yeah, I needed to do a little more change here. Add 3x to both sides, and then add by 3x. Can I put it here? Add by 3x. Yeah, this might. Yeah, this. Let's do this fashion. Add 3x to both sides. So clearly, 3x is cancelled from the right-hand side. And now we are having the equation y plus 3x equals 5. And remember, it's about addition. You know, we have the commutative property for addition, so which really is the same as 3x plus y equals 5. So a linear equation, and this fashion, it is considered as the standard arrangement or standard form. But we could have a linear equation occur in a different way, okay, like in this fashion, the really important thing is it doesn't matter how many variables you have. Whenever we say there is a linear, it is a linear equation, it should be true for all the variables. Among all the variables, each variable, it will have to be in its original fashion, not inside the square root, not in the denominator, not raising to the power, not seen inside this radical notation. That is pretty much, it's about the linear, okay, linearity. Linear equations, all the variables will have to satisfy the same requirement. And now, as we mentioned earlier, when we have linear equations, there are many solutions. So indeed, any chance if you try to all solutions, each solution of linear equation, it is an ordered pair. And then if you plot all the points together, indeed you will see. Can you imagine how the graph would look like if we are having a linear equation like in this fashion? We call it a linear. So indeed, the graph or linear equation, it is a straight line. It is a straight line, okay? It is a straight line. So let's take a quick look. When we have an equation, how do we really get that a straight line? So to graph a straight line, make the straight line for a linear equation, what you can consider here is you want to choose ordered pairs. And also some things for you to consider when you choose ordered pairs. Hopefully you still remember there are infinite solutions, right? So we have infinite solutions. We do have a lot of choices, okay? Some things you may want to consider, you want to make some simple and easy choices. If all possible, you want to start from 0, or 1, 2, 3, or -1, -2, -3, those things, okay? And in particular, I just want to mention when x equals 0, remember we mentioned earlier, when you have ordered pairs such that x coordinate is 0, it just turns out to be a point on the y-axis. So you need a linear equation wise. When you make x equals 0, you are finding the so-called y-intercept with the linear equation. So when x equals 0, in this particular case, we are having y equals 3, which means the y-intercept it is 3. Okay. The first point to graph a linear equation, you want to plot points. Okay. Choose a few of them. Make some simple and easy choice. And certainly the next one you could do 1 or -1. But I'm seeing there is a coefficient of 1/2 of x there, right? And sometimes we will have to deal with fractions. We have to deal with decimal numbers. But it would be easier if we could try to avoid those fractions or decimal numbers. So accordingly on the textbook, or the second value the textbook is choosing for x, it is just 2. Because when we make x equal 2, we don't have to worry too much about the 1/2. So accordingly, y equals 4. And then we make x equals 4, and then y equals 5. We can make many of those choices, okay? The idea should be very simple. Make some simple and easy choices, okay? And if all possible, avoid fractions. So that's what we did. And then we got 3 points. We plot those 3 points into the same xy plane. So we have 3 points. And it's not just by chance, okay? As long as you get those ordered pairs or points correctly, it will have to be true. All the points, they got to be on the same straight line. So this indeed turns out to be this line, okay, the straight line can be extended to anywhere to the right or to the left or whatever the direction arrow points to, turns out to be the solution of that linear equation. And this matches perfectly as we stated in the beginning. A linear equation has infinite solutions. There are infinite number of points on the straight line. But anyway, any point simply just a solution of the equation. And indeed, that's the reason why we call such an equation as a linear equation, because the graph matches perfectly as a straight line. The graph matches perfectly as a straight line. So this topic, this lecture, it is a topic for the graphs of linear equations. Keep in mind, when we say an equation is linear, and basically we are saying, okay, the variable, it does not carry any powers or exponents, and it is not in the denominator, it is not inside any radical notation, so that is linear. And the graph of a linear equation, it is a straight line. And to plot that straight line, you want to consider plot points like we did. And also, I really want to mention one more thing. Indeed, if you see it clearly, okay, as a linear equation, to draw the graph, you only need to have 2 points, because it is just true. When we have 2 points, a line, it is just fixed, okay. And also 2 common choices to plot a straight line. You may want to consider plot the x-intercept. The first one we chose here, it is clearly the x-intercept. It is a y-intercept, okay. The y-intercept, it is a point on the y-axis. We did not choose the x-intercept. By the way, anyone can tell what is the y-intercept for this linear equation here? If you only look at the graph, the y-intercept, it is at 0 and 3. The x-intercept, it is at -6 and 0. Okay, so again, the x-intercept, it can be found by setting y equals 0, and the y-intercept can be found by setting x equals 0, because x-intercept, it is the point where the graph crosses over the x-axis, and the y-intercept, it is the point on the graph where the graph crosses over the y-axis. Again, this is section 5.5. It's about graphs of linear equations. Thank you for watching.